In exercise 8, we have to simplify the expressions and also make assumptions. So, as we all know, when I'm dividing something, the denominator shall not be 0. So in this case, I assume that x does not equal 1. And that's it, my assumptions are completed. Now, if I want to simplify this expression or any expression, I always start with looking at the numbers. Because simplifying between numbers is the easiest thing to do. You can see that 3 is divisible by 3 and 9 is divisible by 3. So I will simplify this right at the start. I can factor this expression. X squared minus 1 can be written as x plus 1 times x minus 1, and in the denominator I have x minus 1 times 3. Now let's take a good look at this, and oh, what do we see? We see that we can further simplify this expression with a factor of x minus 1, and finally we got x plus 1 divided by 3, and I cannot simplify this any further, so this exercise it's complete. And our last exercise for today is exercise 8b. We have to simplify this expression and also make assumptions. Now, you can see that we have quite a few denominators here. There is a simple one, x minus 4, and there is a little more complex one, but we will get to it. So first, the assumptions. First, let's start with the easy one. Assume that x does not equal 4. This way, we have tackled this denominator and this denominator. But we also have a big denominator here. So let's assume that 2 times x does not equal to negative x plus 3 divided by x minus 4. We don't have to make another assumption here because we have already assumed that x does not equal 4. The problem with this is that the assumptions are always telling us something about x. For example, x does not equal 4, or maybe x is greater than 0. We should find a way to get more information out of this expression. So, well, let's solve this equation. 2 times x equals negative x plus 3 divided by x minus 4. We have already assumed that x does not equal 4. I will multiply this equation by x minus 4. So on the right hand side I have 2 times x squared minus 8x. This was the left hand side, and on the right hand side negative x minus 3. I will add x and 3 to this equation and I get an ordinary quadratic equation. 2 times x squared minus 7 times x plus 3 equals 0. Let's use the formula to calculate the roots. x12 equals 7 plus minus root of 49 minus 24 divided by 4. The two roots equals 3 and x2 equals a half. So I can get back to the assumptions. I assume that x does not equal 3 and x does not equal a half. Now I have cleared some space here. We have the assumptions down, so let's go to the next step. I will unify these expressions. The common denominator is x minus 4 in both cases, so both in the top fraction and in the bottom fraction. In the top fraction, we have 2 times x squared minus 8x plus 13x minus 3. In the bottom fraction, we have 2 times x squared minus 8x plus x plus 3 divided by x minus 4. I can see it from the get-go that I can simplify this expression by a factor of x minus 4, and what I got is 2 times x squared plus 5x minus 3 in the numerator, and in the denominator I have 2 times x squared minus 7 times x plus 3. Does it ring a bell? Let's factor these out. For the numerator's factorization, I will have to write the quadratic equation for this numerator and solve the quadratic equation. So the equation in question is 2 times x squared plus 5x minus 3 equals 0, and here comes the formula, x 4 equals negative 5 plus minus square root of 25 plus 24 divided by 4, and the two roots are x3 is negative 5 plus 7 divided by 2, that is 1/2, and x4 is negative 5 minus 7 divided by 4, it's negative 3. So this comes to the numerator x minus 1/2 multiplied with x plus 3, and in the denominator x minus 3 times x minus 1/2. And I can see that I can further simplify by x minus 1/2, and the result is x plus 3 divided by x minus 3, assuming what we have assumed from the beginning. And this was for the second week.